Hi prospective students, my name is Professor Justin Pang of Singapore Institute of Technology, SIT, and together with me today we have Prof. Ulf Sklichman from Technical University of Munich, or TUM, and the title of our talk today is Empowering the Next Generation of Engineering Digital Workforce, and we are going to introduce this SIT and TUM undergraduate program. This is a 4-year Bachelor of Engineering Honours program, also called as the Electronics and Data Engineering, or EDE. And without further ado, may I invite Prof. Ulf Sklichman from TUM to give the first part of the speech to introduce us on this talk. Thank you, Prof. Sklichman.
Hello, a very warm welcome to all prospective students of SIT and Technical University of Munich. My name is Ulf Sklichman. I'm a professor at Technical University of Munich. You can see our famous clock tower here in the background. I'm talking to you from Munich, and I will be giving this presentation jointly with Professor Justin Pang of Singapore Institute of Technology. What we want to do in the next 30 to 45 minutes is give you an introduction into our program in electronics and data engineering. It is a 4-year Bachelor of Engineering program, an honors program. And we feel that this will really be the key program to empower the next generation of the engineering and digital workforce in Singapore. And 2 institutions have teamed up to deliver this program, which are really well positioned for this task, which is the Singapore Institute of Technology and Technical University of Munich from Munich, Germany. Here's an outline of the presentation. We will first give you a brief introduction to the 2 institutions, SIT and TUM, and then we will introduce the Electronics and Data Engineering, EDE in short, program, and discuss the curriculum as well as admission requirements. Let's start by taking a look at SIT. On the next slide, you can see some core values, core characteristics of SIT on the left-hand side, and some key data on the right-hand side. Starting with the core values on the left-hand side, there's the applied learning pedagogy, which is very important to SIT, and that's something that TUM also values. We are a very well-established, research-intensive university, but education plays a very important role to us, and we collaborate very strongly with industry. And thus, we focus on a fundamental education which will last our students really a lifetime, but at the same time enable them to get a head start into industry right after graduation. There is the global exposure, obviously, with 2 institutions, one from Asia, one from Europe. That is a given. There's also, I mentioned, strong industry partnership already, which is important to SIT as well as to TUM. And the program also includes IWSP opportunities, so the Integrated Work-Study Program, where students are able to merge their academic studies with getting practical experience from industry already during their studies. On the right-hand side, you see some key figures. More than 90% of the students manage to secure a job very rapidly after graduation. Almost 90% of applicants get to attend the first or possibly second choice of programs. There's a very wide variety of student activities available, and looking a bit forward to your graduation, the median salary of SIT graduates is very attractive. SIT at the moment offers almost 40 degrees. It partners with 7 well-recognized overseas universities, which you see on the lower bottom of this chart here. And there is TUM right in the middle with our blue logo, in addition to other universities. And the programs fall into 5 categories, and engineering and infocom technology. Those are things that probably the people watching this introduction are interested in. Moving on to Technical University of Munich, on the next slide. Here you can see our main entrance. We are a very well-established university. TUM was founded more than 150 years ago and is very well-established internationally. I will talk in more detail about TUM on the following slides. So the next slide shows you we're located in Munich. You see here in the background the picture of the Munich city center, the very famous Marienplatz with our city hall, which looks a little bit different than City Hall in Singapore, but it is very well known internationally. In normal times, it will be full of tourists touring City Hall and its surroundings. As you can see on in the small inset picture on the left-hand side, our main campus is located very close to the city center, right downtown. In Munich, what you see there is actually the view from one of our campus buildings. You see a famous Munich church there, and in the background you see mountains. That's the Alpine Mountains. They are about 1 hour by car or by train away from the city center. So that's something very nice to do in Munich. To go to the mountains for hiking in the summer, for skiing in the winter time. Munich is actually well recognized in Germany and in Europe, not just as being a high-tech center for all of Europe, but also for the very high quality of living. We work very successfully, but there's also great opportunities for leisure and enjoyment. Munich is the third largest city in Germany. We have about 1.5 million inhabitants. By Asian standards, that's fairly small. By European standards, it's a fairly well-sized city. We are student-friendly. We have significantly more than 100,000 students at the various Munich universities, with TUM more than 44,000 students by now, being one of the two large universities. Oh yeah, and the slide also says we're home to the annual Oktoberfest, which you may have heard about, but I think we should be focusing on our studies now. This next slide gives you a little bit of an overview of how TUM does in rankings. We are, based on various rankings, #1 university in Germany. And from that, of course, it logically follows that we're also the #1 technical university in Germany. Our electrical engineering program is ranked #1 in Germany. And another ranking, which we are really very proud of, is the Global Employability Survey, which is conducted by Times Higher Education in the United Kingdom. And they have ranked TUM #6 globally for a number of years. So in terms of how companies value and assess the quality of the graduates, how well they are employable, how well they integrate into an industrial environment, we are ranked #6 globally. So that's something we're really proud of, because it shows the quality and the reputation that our education enjoys in industry. So what you will be getting is an internationally recognized degree. TUM is ranked among the best European universities in various international rankings. We focus on excellence both in research and teaching, and also strive for an interdisciplinary education. And just like SIT, we focus also on applied research, applied education. So we have strong links with companies and scientific institutions on a global scale. And as you can see on the slide, that all results in happy students. And we hope that in short time, you who are watching this video at the moment will become part of this group of happy and well-educated students. TUM has actually 6 major locations. Most of them are in Munich and its surroundings in Bavaria. On the lower right-hand side, you can see Heilbronn, which is our newest satellite campus in the southwest of Germany. But very important, what you see in the middle, in the lower row, that is our Singapore location, which is our only location outside of Germany, and which we have been building up for about almost 20 years now. So we have quite a bit of history, and I might want to add successful history here in Singapore, more than 10 years of collaboration also between TUM and Singapore Institute of Technology. So by joining this program, you are joining a well-established collaboration. Here at one glance, what are the advantages of this joint degree which we are offering? You get the collaboration between SIT and TUM. So as I said before, the best of both worlds, an Asian perspective, as well as a European and German perspective on research and especially on education. You will get to apply emerging digital technologies, which are about to revolutionize the electronics and semiconductor manufacturing industry, which of course are very important to Singapore, as we will see. We have the integrated work-study program as part of this program, and about half of the teaching will be done by TUM professors who will come to Germany to actually conduct their classes on site in Singapore, teaching you, working with you. So let's talk briefly about the relevance of the electronics industry in Singapore. It achieved already 5 years ago $65 billion output, which is about 1/3 of the total Singapore manufacturing output. The industry exhibits 2 to 5% annual growth in productivity. And that's very important because that means it's getting more competitive all the time. There is almost 70,000 workers in this sector, accounting for 17% of Singapore's manufacturing workforce. This is a fairly significant part of the Singapore economy. And the lower part of the slide shows you just some highlights. Quite likely every key gadget that you will be using or people all over the world will be using has some parts which have been created, designed, manufactured in Singapore. For example, hard drives from Seagate, print heads from HP, Hewlett-Packard, all the way to Energizer's batteries. RF filters made in Singapore enable smartphones today, and industrial pioneers such as NVIDIA, Infineon, Micron, they're all pushing the boundaries of artificial intelligence, machine learning, autonomous vehicles, and Industry 4.0, which, by the way, originates from Germany. Singapore is a rich and diverse manufacturing hub for the electronics industry. It addresses semiconductors broadly. There's also memory products or micro electromechanical systems. It's an industry which is looking for industry-ready and innovative talent, such as the graduates of our program, which will also enable the next generation of foundry engineers and integrated circuit designers. The electronics industry is ready for a smart future, and it is really the backbone of artificial intelligence. You will all know that we are experiencing a revolution. Machine learning, artificial intelligence are getting ever more important. What people often don't realize, the foundation for that is the advancement in electronics. So the electronics industry is what really is driving all the marvelous advances we're seeing in artificial intelligence. You can be part of that. With that, I would like to hand over to Justin for the rest of the presentation. Thank you very much, and I hope to see you soon in one of my courses, which I am teaching in this program. Thank you.
Okay, thank you, Prof. Schlichmann, for introducing the first part of the talk. And now I'm going to talk more about Singapore context, which is the second part of the talk. Okay, so why is this EDE program actually being introduced? We actually have sought out and worked with a lot of industries in Singapore, and we have visited these companies, and we realized that the electronics manufacturing actually combined to around 4.4% of Singapore GDP in 2016, hiring a workforce of more than 68,000. And an industrial scan with 17 companies such as Micron, Infineon, and Global Foundries, and in particular, many other local and global MNCs, has shown a healthy demand of more than 290 graduates annually, with expecting starting salary of 3,300. When visiting and discussing with these companies, we have solicited their feedback and realized that the current skill sets required by industries are more and in demand in the areas of digitalization, example, data analytics, preventive maintenance, Internet of Things, etc., in addition to more traditional topics like automation, semiconductor fabrication, ICT integration, power, smart metering, and instrumentation, etc. And in addition to these industrial scans, we also have done some desktop scans, and as of April 2018, we show a monthly healthy demand of 800 vacancies related to positions in terms of Industrial 4.0. Also in terms of area of automation and digitalization. Okay? And top roles which companies are constantly and always seeking for are in areas of electronics engineer, application engineer, test process engineer, equipment engineer, system support engineer, maintenance engineer, etc. And very high-level industrial meetings with these key players other than semiconductors are also ABB, Continental, Automotive, Schneider Lifts, Singtel, Keppel, etc., where electronics-related skill sets are also required. So let's talk about this evolution of the TUM EIT program. When introducing this EDE program, this certainly did not happen just overnight. Okay, in fact, in 2002, TUM Asia actually first ventured its academic abroad by a German university into Singapore. And in 2009, TUM Asia actually partners with SIT to offer what we call the Bachelor of Science degree in EIT, or Electrical Engineering and Information Technology, which some of your seniors are still reading this program. Okay, but after 10 years of very fruitful collaboration with TUM, okay, SIT and TUM decided to evolve and further strengthen this ecosystem of collaboration together into this Bachelor of Engineering with honors in Electronics and Data Engineering, which we are currently offering now. So this actually moves from a purely TUM Overseas University program into currently a joint SIT-TUM joint degree program, whereby we will both SIT and TUM in charge of 50% of the academic activities and instructions for this program. This picture shows where most of the instruction will be held. In addition to SIT at Dover campus, some of these classes will also be held in SIT at SP campus. As you can see, our students actually at this ground floor of this SIT at SP campus. Some objectives and graduate outcomes we hope to achieve for our graduates when finishing and completing this exciting program. What we want is to really equip our EDA students with the necessary skill sets and competencies for this emerging digital data force, which now many industries are sorting after. Okay, and especially in specialized skills relevant to electronics or semiconductor industry, as well as the more upcoming data analytics industry. And we need to fulfill this demand for these engineers with rigorous knowledge in terms of both electronics as well as data engineering, which are both built upon strong foundation in terms of physics and mathematics. So how does this EDE program actually differentiates us from other existing degree programs offered by other autonomous universities or even within our SIT? Okay, so this program has a lot of foundation modules which we try to inculcate with students deep knowledge in terms of electrical engineering fundamentals, including circuit design, architecture, mathematics, data engineering, and machine learning, etc. This degree program was also reinforced with new and industrial relevant modules which industries have actually give us their feedback on. And these are newer topics in terms of semiconductor fabrication, bioelectronics, industrial electronics, Internet of Things, data analytics, and machine learning, etc. in terms of artificial intelligence. So this slide shows a curriculum structure and overview of the 4-year degree program, but which in essence is 3 years, 8 months. Okay, in year 1, trimester 1, when you admit in September 2021, you come in to read the fundamentals, and then for the first year fundamentals, and in the break of the first year occurring in trimester 3. And then in second year, you move on to more fundamentals, core, and a break, and OIP or overseas immersion programs. More details I will talk about it in subsequent slides. In the third year, you move on to study more core and specialization, whereby you are able to take a basket of electives, of modules of interest to you. And finally, in year 4, in our IWSP or Integrated Work Study Program, this is a salient, if not signature program which SIT offers, together with our bachelor thesis, done and read actually at industry where you are carrying out your work attachment under the IWSP. And although this looks like a 4-year degree program, effectively you can complete it within 3 years, 8 months. And in addition to these technical modules, we are also including soft skill modules, as you'll see later in subsequent slides. Okay, so more details on this curriculum structure. Those modules in red will be actually taught by our own SIT faculty and professors. The modules in blue are actually taught by TUM faculty and professors. And what differentiates us greatly from other degree programs is the fact that we fly in the TUM professors directly from Germany to teach us in Singapore and SIT in both campuses in Dover and SP accordingly. In particular, academic instruction that you receive here in SIT under this joint degree program is no differentiable as if you are actually physically in Munich studying the same modules. Okay, so this is very advantageous as the same TUM professors will teach the same modules literally in Singapore to all of you as if you are physically in Munich. Okay, in Tri 3, we also have some red and blue modules by SIT and TUM professors respectively. And those in bold and italic are your soft skill modules, whereby you'll learn other soft skills like report writing in terms of technical communication, and engineering professionalism in terms of project management, engineering ethics, career professional development, and also German, etc. And the modules with a hub sign are actually electives, whereby you're supposed and able to choose from a basket of. So more details on this OIP. You'll spend 3 weeks in year 2, Tri 3, whereby you go to home campus in TUM Munich. You spend 3 weeks attending workshops, industrial visits to various engineering companies, also global experience to network with fellow international students and your TUM and German professors. And also you get to visit some of the exciting research that some of the research institutes in TUM are actually carrying out. So you spend 3 weeks there as an international student and network with your fellow peers to broaden your collaborative network. And this signature or not, if not your salient IWSP program, Integrated Work Study Program, which is offered purely by SIT. Okay. This program is actually very unique, only in SIT. What is important is most of you, after your 12 years of formal education, are actually are actually work ready, but not industrial ready, unfortunately. So with this 8 months of IWSP, part of your work attachment, you get aligned with company or engineering practices and professionalisms, and pick up all these essential tools to be work ready such that upon completion of this IWSP, you can be easily absorbed by the industry as a contributing workforce. So this IWSP can be carried out or actually read locally in IWSP or with possibilities with engineering companies even in Germany or overseas IWSP. Okay, so this duration is 8 months, happen at the 4th year. You work full-time in a host company in the industry, and of course you absorb all this valuable experience in industry, both either locally or globally. And what we hope you can achieve is to blend whatever theory that SIT and TUM faculty has taught you for the past 3 years in terms of academic instruction and with practice that is being adopted by the industries. So being autonomous university and students being able to tap onto the various academic grants by MOE, we need to get support from leading agencies in the government. So this again did not happen overnight as what we have mentioned. We have engaged EDB as early as November 2017 before launching this program. Okay, so we received feedback from EDB on 14th May 2018 saying that given that the latest version of the curriculum incorporates industry feedback and takes reference from the electronics ITM, which is actually provided by the Ministry of Trade and Industry, the proposed program should be able to address industry needs for more electronics and data-trained engineers. And since data is involved, we need to seek approval from IMDA as well, and a thorough review conducted by the subject matter experts from IMDA in September 2019 reveals that IMDA is also very supportive of this EDA program. And finally, on 7 November 2019, last year, we have the formal approval of MOE, and we managed to launch this program this year. So, as mentioned previously, we actually sought out with more than 17 companies of both global and local MNCs, as you can see from here. Some of them might be semiconductor or not, although they are not from semiconductor electronics industries like Singtel, StarHub, or even EMA, etc. These local MNCs are also very interested in the data-trained engineers from this degree program. And you can see, in addition to the electronics or semiconductor industry like Micron, Global Foundries, etc., many MNCs are also very interested in engineers from this program like Schneider Electric, and of course our German MNCs like Continental, Rhodes and Schwarz, and Siemens. Okay, they are very supportive and have also indicated that they require a lot of such engineers which are trained in areas of digitalization for this course. So come to the last slide on admission requirements, which I believe most students are actually thinking of. Okay, so we have actually opened up the funnel slightly a bit, in addition to the traditional way of admitting only more on the articulated diplomas. Okay, we now are looking at polytechnic diplomas, a full-time polytechnic diploma by one of the 5 local polytechnics are eligible to apply. GCE A-level students, IB diploma, NUS high school diploma, or other international qualifications with 12 years of formal education. And an additional note I would like to add is, for all students who are interested in this degree program, please apply if you are also very interested in mathematics and physics, as the underlying principles of most of these electronics and data require a strong foundation and at least interest in mathematics and physics. And with this, I'll come to the end of the talk today. I would like to thank you for your time and hope to see you at the interviews and hope to see you again when you all get admitted into the degree program. Thank you very much.